All right. Well, while people are filtering in, we'll go ahead and begin. Good evening, all. It's a pleasure to see so many faces here. This is clearly an important topic for many of us in the community here in Prince William County and beyond. My name is Ashley Studholm. I'm the Executive Director with the Prince William Conservation Alliance, and we work to establish desirable, equitable, sustainable communities, promote environmental stewardship, and create opportunities for residents to engage in decisions that affect the quality of their lives and the future of their communities throughout Prince William County. We're currently in the process of revamping our website, but in the meantime, you'll still find helpful information about upcoming events and projects that we are working on. Sorry about that, the light just turned off on me. Let me turn on another light so you can see me a little bit better. One event that I did want to highlight is our annual Bluebell Festival on Sunday, April 7th. You won't want to miss it. It's always a really spectacular time, and I hope to see you there. Now, we offer these programs like this one tonight free of charge because we want these programs to be accessible to everyone. However, these programs aren't free to organize and to host, so we're able to do that because of the generous support of people like you. So if you like what we do and want to support programs like these from our website, you can easily click on the donate button and you can securely donate online. And honestly, whether it's $10 or $100, it truly makes a difference. This county is rich in natural and historic resources, spanning from tidal wetlands to a mountain at Bull Run. And we serve as the transitional zone from DC's urban core to Fauquier's rural landscape. Prince William County's suburban to rural landscape holds the line of development pressure radiating out from DC. And this land that the county, the land of the county protects many waterways, and I'd like to highlight two here. The Occoquan Reservoir, which we'll hear a little bit more about tonight, and Quantico Creek. The Occoquan Reservoir is a regionally significant drinking water resource, and Quantico Creek is one of the highest quality streams in the region and is often used as a reference stream. This creek is protected by Prince William Forest Park and a rural area which reduces development pressure at the headwaters. And land use decisions in Prince William County impact these regionally important waterways for better or worse. And through smart growth strategies and conservation stewardship efforts, we can protect and foster what makes this county so great for all residents here and really throughout the region. And tonight's topic really intersects all of these pieces that are critical to our work and conservation efforts. Having reliable, safe drinking water at accessible costs is essential to sustainable communities. But before we jump into today's panel discussion, Why So Salty? Freshwater Salinization, Trends and Regional Impacts, I'd like to go over a few points about this evening. There's quite a big group of us here tonight, so given the size, I'd like to ask that you keep your video off and mic muted. This will just help us run a smooth show with hopefully not too many technical hiccups. We have three panelists this evening, and they'll first present their presentations. During their presentation, if you have questions, please feel free to use the chat feature. We may have time to answer one or two questions between panelists. But after our final presentation, we'll open it up to a Q&A. And at that time, when I call on you, I encourage you to unmute, put your video back on so we can see your beautiful faces, and we can have a discussion. Also here to help facilitate this process is our newest member of the PWCA team, Terrell Worrell. Do you want to unmute and just say hello real quickly?
Hi, everyone. It's good to be here.
And we're delighted that you're here as well. I would like to also recognize a few folks in the audience. I know some have signed up. Anyway, I think I saw just a couple of folks that I wanted to recognize. I believe I saw Supervisor Victor Angry here tonight. And I may have seen a couple of other folks. So I'll give you some recognition at the end once I go through this list of people. And then I would also like to recognize we have a couple of Prince William Conservation Alliance board members. Kevin Parker is with us tonight, and so is Elena Schlossberg. So thank you, everyone, for being here. All right, enough of the prologue here. Let's get into why we're all here together tonight. Our first panelist is Nicki Bellezza, who serves as the Watershed Protection Specialist at Fairfax Water. She has 25 years of experience in the water profession, having been an extension educator with Penn State Cooperative Extension, Reston's Association's watershed manager for 13 years, and now Fairfax Water for over 5 years. She has a bachelor's and master's degree in environmental science and management, and she is the Source Water Planning and Protection Department. She is in the Source Water Planning and Protection Department with Fairfax Water. Nicki, thank you for joining us and getting us started tonight.
Great. Can you hear me?
Yes.
Okay, wonderful. Let me just move this out of the way. Thank you. Again, my name is Nicki Bellezza. I'm the Watershed Protection Specialist with Fairfax Water. I'm here to talk about why so salty, right? What are the water supply impacts and what source water protection can we do? Essentially, that's my job, source water protection. So this presentation is going to go over, get to know Fairfax Water. What are our sources of supply? What is our service area? Why is salt a concern for drinking water? And our 3-tier approach for source water protection. So who are we? We, Fairfax Water, are a drinking water utility only. We do not do wastewater. We only do drinking water. We are a nonprofit authority, and we provide safe drinking water to 2 million customers in Fairfax County and our neighboring counties via wholesale. So what does that mean? If you look at the map, the dark blue in the map are our customers, our direct customers that we sell treated water to. The lighter blue are the counties and municipalities that we sell water wholesale, which then they take and send through their pipes to their customers. We have 2 treatment plants. At the top, you'll see the purple. Can you see my cursor? This purple arrow at the top where it says Potomac River. That's our source for the Corvallis water treatment plant in Herndon. And we also have the Griffith water treatment plant down here and using the Occoquan reservoir. We also purchase water from the Washington Aqueduct, which is run by the Army Corps of Engineers. So, how do we treat the water? How do we get water to our customers? So essentially, we start with the Occoquan Reservoir or the Potomac River, our 2 sources. So from each source, the Occoquan Reservoir goes to the Griffith Water Treatment Plant and the Potomac to the Corvallis Water Treatment Plant. At the water treatment plants, essentially, the water comes in, we add a flocculant to it to get the solids out. We zap it with some ozone. And then it goes through a filter with granulated activated carbon. It has a little biological stuff going on there. And then we put a little chlorine in the end, depending on the season, chloramine or chlorine, and then add a corrosion inhibitor and send it out through our 4,000 pipes that get to water tanks and pump stations that essentially get it to fire hydrants or to your tap. So when you turn on the water, you have safe, reliable drinking water. So that's it in a nutshell. Our wholesale partners are listed here. So Prince William Service Authority, Loudoun Water, Virginia American Water, Fairfax County, Prince William County, Loudoun County, City of Alexandria. I'm not going to name all of them, but we have a lot and they partner with us. So to get a little bit more in depth into our source water supply. So a little background on the Potomac. The Potomac watershed is very large. It spans across 4 different states: Maryland, Pennsylvania, West Virginia, Virginia, as well as the District of Columbia. It's large in terms of the watershed size. When I say the size of the watershed, I'm talking about the size of the watershed that directly impacts our intake. So where our intake is sort of in that red circle there. I can't really tell you exactly where it is, but 1,000 or 10,000 square miles essentially drain to our intake. It's still substantially forested in terms of the watershed at 54%. And then we're talking about the Potomac. So this intake will serve our Corvallis plant. And then the Washington Aqueduct also gets their water near Great Falls, Little Falls area of the Potomac. So this is what I want to talk about now. Focus more on the Occoquan Reservoir. So let's look at the map on the right. The Occoquan Reservoir watershed spans 4 counties. So it's sort of the western Fairfax County, southern Loudoun County, good portion of Prince William County, and the eastern part of Fauquier County. So if you look at the map on the left, we have Dulles Airport sort of at the top here and Warrenton over here. And our Occoquan Reservoir and our dam is right here. So there are 3 main contributors. We have Bull Run up here. We have Broad Run, and this is Lake Manassas as it drains down here, and then Cedar Run as it comes down this way. So please note here, this along Bull Run is the UOSA, Upper Occoquan Service Authority water reclamation plant. So it's a wastewater treatment plant that has advanced treatment and it discharges highly treated wastewater back into Bull Run, which then contributes a sustainable supply to our Occoquan Reservoir. So that is potable, indirect potable reuse. So here's my nice picture of the Occoquan with all the trees. So the Occoquan Reservoir can hold 8.5 billion gallons of water, and it was constructed in the 50s. So the watershed size, so the Potomac, we're talking about 10,000 square miles. The Occoquan, 590 square miles. So it's a lot smaller. And we have 43% forest, and that number keeps going down. 36% urban. So we're getting more and more development as population increases and as time goes by. In the Occoquan watershed, we have 574,000 people. So I was like, if I get my calculator out, I can tell you exactly how many people per square mile, but I'll round up and say about 1,000 people per square mile in the Occoquan watershed. So let that sink in a little bit. 1,000 people per square mile. That is a lot of people. So that's a lot of people flushing their toilets and providing indirect potable reuse. So this picture is a great picture also because it shows that the reservoir itself forms the boundary between Fairfax County on the right-hand side and the Occoquan Reservoir, or the Prince William County on the left side. So why is salt a concern for drinking water? Well, salt has some benefits, but also some concerns. So we need salt to regulate the fluids in our body. We need salt to make it safe to drive in the wintertime when we have extreme snow events. We do contract snow removal and salting. So we get it, right? However, salt is used excessively in our diets. Like if you look at a can of soup, it's extremely salty. Another concern is there's currently no regulatory consequence for high levels of sodium in your drinking water. There's no primary drinking water standard for sodium right now. And with all of this, there's increasing trends of salt concentrations in our source waters and our watersheds. And that could cause potential health problems like high blood pressure, cardiovascular disease, kidney disease, taste issues, and impacts to the environment are already evident. So we're talking about salt. It's not just in our watersheds, it's actually everywhere. So it's increasing regionally, nationally, in streams, lakes, and watersheds. It has increased 20-fold since 1940. The use in road de-icing. So there's a lot of different types of salt. When we say road salt or de-icing salt, it could be a mixture of different things. I'm going to focus on sodium. The issue with sodium, it is not removed through our conventional water treatment process. So whatever comes in goes right back out. And if we have, as we have the potable reuse, we're finding that we have an increasing trend. So like I said before, there's no primary drinking water standard that we have to stick to and meet. There is, however, a drinking water advisory. So EPA set a sodium advisory for 20 milligrams per liter for individuals on a salt restricted diet. That's for people that have cardiovascular disease and other health problems that they have to limit their intake of salt. So the sodium that they can get from their water should be 20 milligrams per liter or less. They also, part of the drinking water advisory is once you hit 30 milligrams per liter of sodium in your water, you can start tasting it. So that's an aesthetic taste threshold. And if you look at our chart, so this is the Occoquan reservoir intake. So when we're pumping water out of the reservoir to our treatment plant, we've been able to measure sodium. And if you look at the brown line, it's kind of mustard color, that is the 20 milligrams per liter EPA health advisory level. The purple line is the 30 milligrams per liter taste threshold. And the red is the trend line. So this graph shows you from 1980 to January of this year. So I just updated it. You'll see in winter of 2022, so let's talk February of 2022, we had 61 milligrams per liter, and we stayed high above this taste threshold for 3 months. In April, it was still pretty high at like 15, or I'm sorry, still pretty high. So we exceeded the 30 for 3 months there. And then in 2024, our January result was 15.7. So we're inching up to that 20 milligrams per liter health advisory. And if you look, you know, the big picture is the trend is in the wrong direction. It keeps increasing, and we would like in the future the trend to decrease, and we need everyone's help in order to do that. So there are ways for source water protection. Let's talk about our 3-tier approach. The first tier is source control. So minimizing impervious cover and pollutants entering the reservoir. So if you look at this picture, Fairfax County is on the north, Prince William is on the south. So you have Fountainhead Park, Sandy Run Park, a lot of forest cover on the northern side of the Occoquan. And on the southern side, you have Lake Ridge Association and a lot of individual little HOAs and development neighborhoods. So if you think about where could salt be coming from, because this presentation is focusing on salt. So if we minimize impervious cover, we should therefore reduce the amount of salt that comes in. So this is from Sujay Koshal that gave a presentation. Reducing sodium inputs or salt inputs leads to rapid and year-long recovery in water quality. Essentially, an ounce of prevention is worth a pound of cure. So if you don't put it on, you don't have the problem in the water. An ounce of prevention is worth a pound of cure, right? We know we're not going to get rid of roads. We know we're not going to reforest neighborhoods. So let's talk about the second tier approach, which is delivery control. How does that pollutant get from the source to our reservoir? Okay, because I'm now thinking like a lake manager. So let's say stormwater BMPs. Okay, so those best management practices are designed to capture and treat stormwater runoff to decrease pollutants entering the reservoir. So here, stormwater BMPs, again, Sujay Koshal did a presentation. They were doing research to determine, is salt retained in stormwater best management practices? And yes, so an infiltration, bioretention, or rain garden, BMPs like those can retain 30 to 40% of sodium. And you can also get chloride buildup in these facilities. So, okay, some delivery control. And the last tier of my 3-tier approach is in-lake restoration. So an example of that is we have a hypolimnetic oxygenation system, which I like to call the bubbler, but this is the HOS system. It's the last resort, it's expensive. However, salt is not removed by oxygenation, and there aren't really any techniques for in-lake removal for sodium. So let's get to the main problem, right? Source water quality issues are becoming more and more difficult as urbanization continues to expand in watersheds that drain to the area above our water intakes. We now face a threat that will require extraordinary measures to address the impacts of increasing salt use in the watershed. Increasing salinity in streams is a threat to aquatic organisms and is becoming a concern for drinking water from 2 perspectives: the human health perspective and also increased corrosivity that could cause problems in our distribution system. I didn't even touch on that very much, but it is a true concern that we have. So the big picture, people trust us to provide them with safe drinking water, something that you need to sustain good health. So our source water mission and vision is to preserve and improve where needed the reliability and high quality of the sources of supply in order to provide safe, ample drinking water, safe drinking water. So just to wrap it up in my 15 minutes, we have noticed a gradual increasing trend in sodium. There's a challenge that salt's not removed through our conventional drinking water treatment processes. You would need desalinization or reverse osmosis. And as we looked at reverse osmosis as an option, we're looking at hundreds of millions of dollars to not even treat 100% of the sodium in our source water. So we're looking to partners and watershed protection methods to try to reduce that. Because the Occoquan, even though it's a small watershed, it's highly urbanized. There are many sources, and Stan, I hope, is going to address some of those and go into that a little bit more. And since drinking water utilities, it's not just us, a lot of different utilities in the region have the same issue. We can't directly control the sources. So we work with partners and groups in both of our watersheds to help tackle this huge issue. So you're going to hear from the Occoquan Watershed Monitoring Lab and the Drinking Water Source Protection Partnership today, and they're our partners, and they're helping us tackle this issue. And I would be remiss if I didn't put a plug in for our grant program. So Fairfax Water provides grants for education or source water protection projects that are within our source watersheds, so that large area. Also water quality monitoring projects. And if you live on the Occoquan Reservoir, you are eligible to apply for a grant to do shoreline stabilization on your shoreline property. For more information, visit fairfaxwater.org/grants, and the deadline for applications is May 15th this year. Thanks, and I'm happy to answer any questions.
Thanks so much, Nikki. A couple of the questions looks like it leads into Dr. Grant's presentation pretty well, but I did want Tom, could you come in and just share your comment, Tom Ligon? If he can hear me. In the meantime, there are a couple of sustainability commissioners here that I'd like to recognize. Randy Freed, Elizabeth Ward, and Stephanie Johnson. Thank you so much for being here with us tonight. And I did see Supervisor Bodie briefly, but I think he popped off. So hopefully he'll join us again.
Yeah, I'm a stormwater monitor, Virginia Master Naturalist, and the work for Veronica Tangeri at the Prince William Soil and Water Conservation District. And we do monthly monitoring with YSI Pro meters, which includes conductivity. But I've taken to doing readings with this little thing, which does a temperature compensated conductivity microsiemens. And looks to me like, I was just looking up on the table, you were mentioning 20 milligrams per liter for drinking water as recommended salt. And
Sodium health advisory, yes.
right. So I'm getting that 20 milligrams per liter would come out to about 42.4 microsiemens on this meter. And what I'm usually reading is 200 and up on tap water when I'm just checking this out. And usually stormwater around here runs usually 200 and above, unless it's really pure rainwater. So I've got crazy little windows all over here. Okay. So the question is, we're really that high? It sounds like we're even what I've been considering good water is 5 times as high as you want for salt and drinking water.
Well, all I can say without getting into Stan's is we take discrete samples. So if we get it a day or two after the snow event, or if we miss it completely, it may not be the true high peak that it could have been.
And that's what this is. I'm trying to catch those peaks. And here in Manassas, even though they didn't use much halite in January, we got some really high levels temporarily up into the thousands of microsiemens. And then so I tracked the peak and watched it coming down, and I'm trying to do frequent measurements during the winter when those levels are high and track how it flushes out and so forth. And this is a $150, no, excuse me, it's a $70 meter. So this is something that would be possible for people to use for citizen science monitoring on a daily basis if they want to.
Well,
So
thanks,
anyway,
Tom.
I'm concerned because it looks like your target is probably 1/5 of what we're actually seeing, if my readings are have any meaning. There's a lot of salt out there.
And that leads us
we
pretty
made
well
a-
into the
We made
next.
a heck of a whack back in the snow in mid-January from the readings I took.
Yeah, thanks, Tom. Thanks for sharing that your citizen science endeavor, and that leads us really well into our next presenter here. So our next speaker is Dr. Stanley Grant, a professor of civil and environmental engineering at Virginia Tech, stationed at our very own Occoquan Watershed Monitoring Lab. He studies the fate and transport of environmental pollutants in water with a focus on pollutant attenuation in green stormwater infrastructure and in natural and restored streams. In collaboration with researchers from around the world, he is currently developing a grain to globe modeling framework.
Has everybody signed it?
for addressing, sorry about that, for addressing nutrient pollution at reach, watershed, and continental scales. Stan, I'm delighted you're here with us. Please take it away.
Thank you, Ashley, and thank you for inviting me. And just to kind of riff off of Tom's question, Tom, I think part of the problem is that your table probably is assuming that you start with DI water and then add a certain amount of sodium chloride. But in reality, in the environment, when you go take a sample or a measurement in like a river, it isn't just the sodium and the chloride. There's many other ions, and so that's why there's such a difference between what you would expect for sodium alone. It's not a one-to-one relationship. Although you can do correlations between sodium and specific adductants, and so you can certainly, but they're very kind of location specific, and they might be time specific too. So, but anyway, that's kind of what's going on there. I wanted to share with you some of the work that we've been doing at the Occoquan Watershed Monitoring Lab related to addressing the sort of salinization in the Occoquan Reservoir and then kind of more nationally and globally. As part of a National Science Foundation Growing Convergence Research Grant that the lab has been leading. It's a $3.6 million 5-year research program involving bringing together social scientists, biophysical scientists, engineers, and so on to really try to tackle the problem from all angles. And Nicki really teed me up. Great, thank you, Nicki. And that's actually Sujay. So if you wanted to put a face to a name and a really incredible individual as well as an incredible a researcher, really so lucky to have him, professor at University of Maryland. But anyway, he's part of our team for this GCR project. And so I'd like to start with this picture, but it includes professors from University of Maryland, Johns Hopkins, Vanderbilt, and a couple of other NC State University, but really centered at Virginia Tech and the Occoquan Lab. So I'll kind of share with you some of the results from that. So some of this is a little bit repetitive, but maybe repetition isn't so bad. The Occoquan Reservoir, as Nicki mentioned, is the drinking water source for up to 1 million people in Fairfax County and surrounding communities. It's one of the first and largest, what we call deliberate indirect potable reuse projects for surface water augmentation in the country. It's a lot of words, and I'll explain what that means visually in a second. But the reservoir receives inflow from 2 major watersheds, Bull Run and the Occoquan River, ungauged inflow and treated from the Occoquan Service Authority. So that's the indirect potable reuse bit. So here's kind of a graphic that explains what's going on with this, what we call a one water system. So what do we mean by one water? It means basically that you can't just manage, one component of the system in isolation, because basically the whole system is connected, and more watersheds around the nation, around the world, as we urbanize, our populations grow, are becoming one water systems if they weren't already. The Occoquan Reservoir is kind of at the forefront of that. It's been a one water system, deliberately so, for almost 50 years now. So what do I mean by that? Well, the Occoquan Reservoir is kind of here in this block diagram. Again, it receives inflow from the Bull Run watershed and the Occoquan River watershed. And then this wastewater treatment plant, the Upper Occoquan Service Authority Reclamation Facility, discharges to Bull Run. And so they're basically adding flow that's coming into the reservoir. There's we have gauges. The Occoquan Watershed Monitoring Lab actually maintains gauges for these 2 tributaries, as well as many tributaries sort of upstream in the watershed. But there are, the sort of land surrounding the reservoir, and some of the land just upstream, basically, the drainage from that is not gauged. In other words, we don't measure it. And so we would call that ungauged. So there's ungauged inflow to the reservoir as well. But about, I don't know, 70–80%, depending on what time of the year, of the inflow to the reservoir, or maybe even more, is coming from basically these 3 components: the wastewater treatment plant, the Bull Run watershed, which includes runoff and groundwater inputs to the stream, and the Occoquan River watershed, same thing. outflow from the reservoir includes abstraction from the Griffith Water Treatment Plant, and then also water over the dam or through the spillway into the Potomac River eventually. It flows eventually landing in the Potomac. So that's kind of a big 30,000 foot view of how the system is kind of put together. When I first got here, I saw this graphic, and actually it's an older graphic. It isn't really accurate, but it's kind of compelling. So again, you have that Bull Run tributary, the Occoquan River tributary coming into the Occoquan Reservoir, going into the Griffith Water Treatment Plant, under treatment, going into the water distribution system, going to homes and businesses in the community. And this is where it gets a little inaccurate. It looks like a closed loop. It's basically sending the sewage that's generated from that water use to the Upper Occoquan Service Authority. They treat it and it goes back in. So that's not actually true. It's not one big loop. There might be some of that water that's making it back into UOSA, but by and large, what's coming into UOSA is coming from the Potomac River. So it is actually more of a one pass-through system. I think this cartoon was probably put together before the Potomac, before Corvallis came online. So this is a more realistic view, a less pretty view of the system. Again, you have, for the region, you've got basically these three major water sources. You have the Potomac River, Lake Manassas, and the Occoquan Reservoir. And in this one water system, they're all kind of connected, right? So I'm going to kind of walk through a little bit what I mean by that. So the Potomac River basically is the source water for the Corvallis Water Treatment Plant. And then the treated water from Corvallis flows through retail and wholesale distribution systems to homes and businesses. A lot of that sewage that's generated, not all of it, but a lot of it goes to UOSA, which then goes through Bull Run to the Occoquan Reservoir. So you can see that actually what's happening here is that we're importing through UOSA, we're importing water from the Potomac River into the Occoquan watershed. So it's a sort of trans watershed water transfer, basically. And then that water from the Occoquan Reservoir goes into the Griffith, one of the outputs is the Griffith Water Treatment Plant, which then flows into retail and wholesale customer distribution systems. And then eventually that sewage that's generated goes to wastewater treatment plants, other wastewater treatment plants regionally that by and large discharge to the Potomac and its tributaries. And if you just focused on Fairfax Water, Nicki showed you a graph of sodium ion concentrations changing over time at the intake to the water treatment plant. This is looking at the finished drinking water coming out of the Griffith Water Treatment Plant, and you can see that really strong increasing trend really from about 1980 to present. And not only is the sort of baseline increasing, but the extremes that we're seeing are increasing as well. And just to remind you, the EPA advisory for extremely low sodium restricted diets would be 20 milligrams per liter. So that's about here. Virtually all of the measurements that we have in the finished drinking water are above that 20. The drinking water, the sort of taste thresholds at 30. And so you can see about half or so of the measurements are above that. You might ask, well, how bad is it really? I mean, this is, you're just looking at a trend. Maybe that's not such a big deal when you look at it kind of across the state. And so one of my students worked with the Virginia Department of Health to pull down all of the sodium monitoring data for all public water systems in Virginia, and then basically parse that data by years. So this is basically blues 2003 to 2007, green 2008 through 2012, kind of a darker green 2013 to 2017, and then most recent is orange. And then basically just plotted them as a cumulative distribution. So basically the idea there is you can kind of come along in the horizontal axis, any concentration, say 10 milligrams per liter, go up. And then you find out that about 40% of those public water systems have a sodium concentration less than 10 milligrams per liter. And the dots here show Fairfax Water's sort of ranking there. And so basically back in, the early 2000s, they were about 75th percentile for sodium concentrations compared to all other surface water, public water systems that derive their drinking water from surface water. And then in the next decade, they moved up to 83rd percentile. And then in the next decade, they moved up to 93rd percentile. And so basically, they've been marching up this curve. So whatever's happening in the Occoquan Reservoir in terms of, sort of increasing sodium concentrations is definitely not necessarily mirrored across the state. We definitely see increases, but not really. You might be a skeptic and say, but what about groundwater? And absolutely, groundwater, if you look at all the groundwater, the public water systems across the state that rely on groundwater, that the water tends to be a bit more salty. And so relative to, if you compare Fairfax Water, finished drinking water at Griffith, to all of Virginia's public water systems that rely on groundwater, that percentile drops to about 68th percentile. But it's really a little bit like comparing apples and oranges because Fairfax Water is deriving their water from surface water, not groundwater. But just to be really complete, that's so somewhere between 68, 70% and 93 percentile in terms of the rest of the state. Also plot all of that Virginia Department of Health data for public water systems on this kind of plot where we're plotting sodium ion concentration on a log basis. This is like a Richter scale. So, every major tick is another 10-fold increase. So we're plotting sodium versus chloride across the state. The blue are groundwater, public water systems that rely on groundwater. So you can see they stretch into really high concentrations. Some of these drinking water sources are really horrible. And then, and then you see the surface water here in orange. And we basically made the size of these symbols equal the surface population. So you can see Griffith and Corvallis. Corvallis, remember, derives its water from the Potomac. They basically are kind of, in this 20 to 40 milligram per liter range on a median basis. But they also service many more people. So collectively, a couple million people compared to these, public water systems that rely on groundwater, which typically service less than 1,000 people. So the impacts are also potentially much larger, as you move up this curve. What's driving this trend? I mean, it's a little bit like if you've ever read Jerry Diamond, he talks a lot about, why civilizations collapse, right? There's sort of proximal reasons, like somebody went and cut down the last tree, right? And then there's ultimate reasons, which basically have to do with a set of circumstances that kind of made that proximal reason almost inevitable. And I think the same thing's happening here. We have proximal and ultimate causes of salinity increases. The ultimate cause is really just population increases in the watershed. And so this is population density. Nicki mentioned this, going from really rural regions, areas within Fauquier County, for example, to much more densely populated, over 1,000 people per square mile, in the sort of central regions of Prince William County, Fairfax County, some of Loudoun County, and so on. Woodbridge is down here. This was back in 2005, right? So this was the pattern in 2005 spatially. If you go to 2020, and I'm just going to throttle back and forth here for a second, you can see what's happening, basically, that the population density spreading out like an amoeba, and that's going to have impacts, right? As the number of the amount of impervious surface increases across the watershed, that has impacts, and I'll show you that in a minute. This particular we're using what's called the transportation analysis zones here. That's what the polygons are. And one of the cool things about the TAS is we can essentially look into the future because these are planning documents. So all the local governments have basically come together and said, this is what we expect for growth. And when you go out to 2035, that amoeba just keeps growing. So, so I think one of the real lessons here is that as the so population densities increase progressively in this watershed, and the water that is moving through that watershed ultimately ends up in a drinking water source for up to 1 million people. How do we balance that, protecting the water source versus, all of the potentially economically viable and important reasons to develop as well? I don't know the answer to that, but that's why we have social scientists on the team too. I'm director of the Occoquan Watershed Monitoring Lab, and so basically that's a partnership between Virginia Tech and many other agencies and the Department of Environmental Quality, including Fairfax Water, in the region. And our mission is basically to develop and test cutting-edge transdisciplinary solutions to emerging water quality challenges, using the Occoquan Reservoir in Northern Virginia as our experimental test bed. So that's our mission statement. And I personally think that this field site, not only is the research that we're doing, important and impactful in terms of quality of life and protecting the drinking water supply, but also the lessons that we learn are potentially transferable to many other locations around the state, the sort of nation and world, really, I think. How am I doing, Ashley, on time?
You have a couple more minutes.
Okay, cool. So one of the things I wanted to do was just kind of give you a tour of the impacts of imperviousness on salinity. In this case, measured, Tom, in terms of your favorite, the stream-specific inductance on the vertical axis here. And the Occoquan Watershed Monitoring Lab has a number of stations indicated here throughout the watershed that we've been monitoring for a very long time, probably 20 or 30 years or more in some cases. And so what I've done is I've taken each of the sort of measurements, all the measurements, and this could be in some cases thousands of measurements, hundreds of measurements of specific inductance at each of these stations. So ST70 here is just upstream of Lake Manassas, for example. ST25 is over here on Cedar Run, and so on, so forth and so on. And I've arrayed them by the percent imperviousness in the catchment that drains to that station, right? So ST70 has the honor of having the lowest percent imperviousness in its catchment. But then we go to ST50 on Cub Run, which is right here, and it has the distinction of having the highest of the stations that I've, kind of listing here anyway, the highest percent imperviousness in the catchment draining to it. And then what you're seeing is basically, these are called violin plots. It's just a way of representing how dense the data are around a particular value of stream specific inductance, and the diamonds are the median values. So the way to think of it is basically it's a measure of like how clustered the data is around a particular value. And so you can see the general trend, right? That if the imperviousness that's draining to a station is low, the stream specific inductance is low. So Tom, you were talking about 200. This is about 200, right? So about as low as it gets. But then as you move up, basically not only does the median tend to increase, but the extremes tend to increase too. The one exception here is ST45, which is downstream of UOSA, and UOSA is actually contributing salinity. And so that's why the median value is a bit sort of out of sequence here. But here's the tour. So yeah, starting above Lake Manassas, moving into—
Hey, Stan.
Yeah.
Could you just briefly explain, we had a question in the chat that's relevant. Could you explain imperviousness?
Oh, yeah, absolutely. So basically imperviousness. So when we came into the watershed, before anyone got here, what was it? It was basically forests and open water and riparian zones, and it was in natural setting like a park. And then what did we do? Well, we wanted to build homes and roads and everything that goes along with that, parking lots and grocery stores, on and on. And everything that we built basically changed the landscape from a pervious landscape that is basically the water infiltrated into the soil and then into the shallow groundwater and into the deeper groundwater and then eventually to the streams and so on. So we changed that hydrology to one in which basically now when the rain falls, it hits surface where that water cannot infiltrate. But the water has to go somewhere. And so that's why we need storm drain systems, because it then whisks that water away very quickly, unfortunately, into streams, causes the streams to have way more water during storms than they would have under natural conditions, and then a lot of other ecological and water quality impacts. So that's like a year-long course condensed into maybe a 2-minute explanation. Does that make sense?
Yeah, thanks, Stan. Go ahead.
Yeah. So anyway, we were just doing a walking tour. So, basically the areas of the watershed which don't have that development, right, are relatively natural. That's another way to think of it, natural to more kind of urban. Basically, those natural areas tend to have very low specific adductance, and then we kind of march up the curve until we get to ST50, which has the highest level of development. So anyway, that's one way to think of it, is that basically with people, as the people move into the watershed, comes a fundamental change in the hydrology, where we put down all this imperviousness, and then to prevent flooding, which can be horrible, we create storm drain systems which move that water to the stream very quickly, and that has like a cascade effect of water quality and hydrologic problems. So, so I mentioned our growing convergence research project. We're basically in year 3.5 to 4 of that 5-year project. And so basically our entire focus is really on reversing freshwater salinization and trying to get all the major parties to collaboratively work on it together, because it really is, it's not just runoff. I mean, that's certainly a de-icer runoff, and de-icer contribution is a big part of it. It's also the reclaimed wastewater. And you might say, well, let's just, get UOSA to stop putting all that salt in its wastewater. But the fact is they put very little salt in their wastewater. Most of that salt is coming from us. It's coming from what we put down the drain. It's excretion, right? So our diets are salty, and that salt has to go somewhere. And then it's also industries like Micron and so on that would contribute, a significant portion of the sodium that's going in there as well. And then on the water treatment side, there's salt that's being added as well. So it's a very complicated, multi-sector problem, and it's kind of a structural issue, because each of these components of our water system are managed separately. So our project is really about how do we bring everybody together, do the science that we need to do to understand the problem, and then try to work towards solutions. And here's kind of the summary slide, if I may. Ashley, are we still okay, or should I shut up?
You can wrap up with this one.
Okay, yeah, I've actually 2. But yeah, so basically one of the questions we're trying to answer is, how will salt concentrations increase under business as usual and drive the increase? So if you think of the ion concentrations, and we're kind of here in time, and then this is, our children, our grandchildren growing up, and so on. And we're kind of, our concentrations, our current concentrations are kind of in this range, and we're flirting with the taste threshold or sometimes over it. But there's also ecological thresholds where we could see ecological collapses, no more fish, or none of the this sort of fauna that support fish. And then human health thresholds. And you could argue maybe we're out sometimes, like when we have a de-icer, we're already here, but let's be generous and say we're actually at this point. Well, as population increases, as climate changes, what does that trajectory look like? And then also, what is the breakdown, right? We have de-icers and anti-icers, we understand that, but we also have water and wastewater treatment processes that contribute salt. We have what we pour down the drain and our industrial discharges that contribute. And then we have geology. We have natural sources, but we also have legacy pollution. Nicki mentioned using green stormwater infrastructure to capture de-icer runoff. But if that's not done smartly, what happens is we just turn a surface water problem into a groundwater problem, which can be even in many ways worse because it's harder to mediate. It's going to keep doing a favor. It's going to keep basically bleeding that salt out to streams over many, many decades. And so then this is the last slide. You know, our focus really is what can we do collaboratively to slow or reverse these salinization trends? And, you know, some of the things we're looking at are best management practices in the watershed, like those green stormwater infrastructure systems that Nicki mentioned, but also looking at, you know, sort of collaborative agreements, you know, surrounding how salt will be managed in the system in the absence of that regulatory hammer that Nicki mentioned, or maybe regulatory hammers are needed. Education, social marketing is super important, and then of course there's, you know, options for DSCR alternatives as well. But the goal is really to try to at least hold that trend steady, you know, hold those concentrations steady, not allow them to increase. But ideally, we'd like to reverse the trends entirely and bring the salt concentrations back down. So with that, I'll stop and thank you again so much, Ashley, for allowing me to speak and represent Virginia Tech and the Occoquan Watershed Monitoring Lab.
That's terrific. Thanks so much, Stan. Looking at the time, actually, Roger, do you want to come in and ask your question quickly about the model? I think that was pertinent to Stan's presentation. So we'll ask one question and then we'll move on to our final panelists. Oh, but before you do, Roger, there were a couple of people that I wanted to recognize. Harry Wiggins with the Chesapeake Preservation Review Board, and Norm Goulet from the Northern Virginia Regional Commission as Senior Planner and the Occoquan Program Manager. Thank you both for being with us tonight. Roger, do you want to come in quickly?
Yes, I just had to figure out how to unmute. The question is for Dr. Grant and others, so where do we stand on developing a better model that would, for land use decisions that we'll be able to look at development in smaller parcels?
Thank you, Roger. Yeah, no, I know that you're passionate about that. A lot of people are passionate about it, so it's an important question. So as you know, we've talked previously. The lab has kind of been nurturing a watershed scale model, district watershed scale model for probably 20 or 30 years, and a lot of that was really developed by Dr. Adil Godrej, and then in collaboration with Norman Goulet, who's on the call today. And so what's happened, he passed away tragically a couple of years ago, and so that the sort of torch was passed to a really incredible modeler, Sardar Saxena. And so he's really taking it kind of quantum leap, I would say, in terms of you know, the kind of information that we can get out of the model, you know, real estimates of kind of error associated with you know, predictions, which is a really important thing if you're if you're basically saying, well, what happens if land use changes, you know, in this particular location, and you get an answer. You really want to know what the error bounds are on that, because you might make a policy decision that's really within the noise. And then also associated with that are just smart tools for thinking about land use changes. You know, a development doesn't happen in isolation, right? There are things going on all over the watershed that are all collectively contributing to what we're seeing in the reservoir. And so so you really need to be able to project not only what's going to happen in you know, the particular location or a particular policy issue, like for example, data center build out, but also, you know, how that is embedded in a larger change over time. And what he's been doing, I mean, I think we've all probably had some experience with you know, large language models like ChatGPT and AI, and I don't know about you guys, but it's astonishing, right? What they can do, what they can learn. And so he's leveraging some of those machine learning tools to basically create what I would call sort of first cut estimates of what might happen into the future, that then those can be passed out to planners and so on to vet and assess. And then that information, because in the end, right, it's garbage in, garbage out. So anyway, a lot of really exciting things happening with the model. I'm just thrilled that Siddharth has taken it, and Norm has been amazing in terms of being a great partner on that. And I think that, but I also, I think you have to temper enthusiasm a little bit, because models are not crystal balls, right? So they're very useful tools, and I think this one will be, but it's not going to tell us everything we want to know.
Thanks, Stan. I think it is really important to point out the cumulative impacts, and so any decision isn't made in isolation, and that needs to be taken into account also. We have a lot of questions rolling in, but I want to move on to our final presentation today. And then we'll open it up to the Q&A and go through some of these terrific questions that are coming in the chat. And I see that there are folks responding to these questions there. So Nicki and Stan, feel free to jump into that conversation, and this will be shared with everyone at the end. I can share the chat with everyone also. So our next speaker, we're going to take a step back and broaden our scope to a more regional view. Michael Nardolilli is the executive director of the Interstate Commission on the Potomac River Basin. Previously, he served as the chairman of the board of directors of the Northern Virginia Regional Park Authority, which operators of 33 parks in Northern Virginia, and was president of the Arlington Outdoor Lab and president of the Northern Virginia Conservation Trust. He was selected as a Green City Leader by Washington Life magazine in 2011 and was named a WETA TV Hometown Hero in 2007. We're very fortunate to have him here with us tonight as our final panelist this evening. Michael, thank you so much, and I'll hand the program on to you, and I'll share my screen so we can all take a look at your presentation.
Thank you very much. I don't have many slides, so we'll run through these pretty quickly. Yeah, let's stay on this slide for a little bit. Thank you for inviting me here today. When I was the head of NVCT, the Conservation Trust, I worked with Kim Hosen and the Prince William Conservation Alliance, so I know the organization well. One of my projects here was placing a conservation easement on what is now known as Leopold's Preserve in the western part of Prince William County. And I see also that you had mentioned that I'm on the board of Nova Parks. When you showed the photograph earlier of all those green trees on the Fairfax side of the Occoquan Reservoir and all the development on the other side, part of that is due to Nova Parks. The Northern Virginia Regional Park Authority acquired all that land on the side of the Fairfax side of the Occoquan Reservoir and in Bull Run, and to protect it. So you have these acres and acres of trees. Finally, also I want to mention that significant downzoning occurred in and around the town of Clifton in Fairfax County, which I think was 40,000 acres of land was downzoned. And the particular reason for that was to protect the water quality of the Occoquan Reservoir. So those are three important policy changes or land use changes that have made a real difference. But I'd like to start off today with a story. I hope many of you have seen the movie The Graduate. Those that haven't, I will recall that it's a middle-aged neighbor, tells Dustin Hoffman's young character about the future. And the man says to Dustin Hoffman, the future lies in one word: plastics. Now, when I became the executive director of the Interstate Commission on the Potomac River Basin in 2019, I visited Chuck Murray, the longtime general manager of Fairfax Water, who was about to retire. And I said to Chuck, "You're retiring, and I'm just starting my position here at ICPRB." And I asked whether he had any advice for me. And Chuck looked at me and said, "I have one word: salt." So it's very, very important for somebody who runs a drinking water establishment to minimize the amount of salt coming in. So they were very concerned about the rise in the salt. And the Potomac River supplies 78% of the drinking water in the DC area. So that's really where my focus has been, on the Potomac. But before we get into salt, however, a little bit about who we are at ICPRB. Next slide. So we were approved by Congress in 1940 as an interstate compact. And as you may recall from your schooling, is that two states can't get together unless it gets approved by Congress. And so the jurisdictions, Maryland, Virginia, West Virginia, Pennsylvania, and District of Columbia, joined together to form this compact to protect the Potomac River and all of its water resources. And the Congress approved that in 1940. The United States is the sixth side of that symbol there you see, but they're not a signatory, but they do participate. Now there are other interstate compacts for major rivers such as the Susquehanna and the Delaware, but the five jurisdictions and the federal government. I guess next slide. The five jurisdictions and the federal government appoint 3 commissioners each. And so I have literally 6 times 3, I have 18 bosses. Now the compact establishes the commission as an agency of each signatory jurisdiction. So we're actually an agency of the Commonwealth of Virginia as well as the other states. But the important thing to remember is that we have no regulatory authority. But despite this lack of power, we have done much to improve the water quality of Potomac, such as returning shad to the river and leading a partnership between water utilities and state and federal agencies known as the Potomac River Basin Drinking Water Source Protection Partnership. Next slide. So let's turn to salt. First, the data. The U.S. Army Corps of Engineers operates the Washington Aqueduct and provides drinking water to the Washington, D.C. area. Now, the Washington Aqueduct routinely samples its source of water, the Potomac River, and each year it reports the monthly averages for basic water parameters and several pollutants and metals. Reports since 2001 are available online, but reports from 1905 to the year 2000 had very limited distribution because they were all just handwritten notes. And their legibility had faded over time. So ICPRB helped to digitize this information, which included chlorine levels from 1940 to 2020. And you see that chart there. That's done by a heat map there. So on our website, we have the same data that's shown in a variety of ways, including scatter plot and monthly box plots, but the conclusions are still the same. So what does this chart tell us? First, that chlorine concentrations have risen almost tenfold during the period from 1940 to 2020. Now, we know that the overuse of road salts during the winter months are considered the largest source of chloride levels, but we see here that not only is the river getting saltier, but high levels of salt can be found in the river even during the summer months. So you see on the left side of the screen here the different months, January through December. Now, as you might expect, January and February are the highest concentrations. But if you start over in 1940, there was no dark colors there. And then when you start moving forward in time, you see 2020 is a lot of blue squares, even in the winter months. So salt is becoming persistent, even when salt is no longer being applied. So that's a real critical point. Now, why should we care? Well, salt in the drinking water, and this has gone over before, but as someone said earlier, repeating things are probably a good thing. So when salt in the drinking water cannot be removed cheaply, you have this reverse osmosis that can be done, and it's done usually for water communities that are located close to the ocean, but it's a very costly process. In addition, no one likes to taste the salt when they turn on their tap. And for folks on low sodium diets, that can adversely harm their health. What has not been mentioned too much or stressed too much here is that we have a lot of creatures that depend on freshwater systems in our basin, and they're critical to the food chain, going all the way up to the fish that provide recreational sport. So for those creatures that depend on fresh water, salt is a real killer. All you have to do is pour some salt over a slug, and you'll see what happens when it becomes too salty. So my word to you is that also consider the other animals out there when you're using salt. Now, what are we doing about it? In recent years, we have seen a remarkable increase in the amount of public outreach on this issue, thanks to the many organizations that are repeating the same message. For example, at ICPRB, we helped the Maryland Department of the Environment develop their salt manuals, so they're able to go out and train folks about salt usage. We also did the same thing on the Virginia side, which was called our SAMS project, S-A capital M small s, SAMS project. So that whole idea is to try to get people who are in the field as actually knowledgeable about salt and what can be done to minimize its use. So we're working with nonprofits, government agencies, and water suppliers across the basin, even across the country now. We've contacted folks in Wisconsin and other states out there to coordinate our messaging about winter salt use. And so what we are doing is asking people to shovel the snow first. Shovel the snow first. Use less salt when they use it. A coffee cup with size of salt is enough for your driveway or your sidewalk. And then once the storm is done, to sweep it up, because then you can reuse it, and it's not doing anybody any good sitting on the ground and just washing into the streams. So, I mean, from my personal point of view, this winter, even though I have a large driveway, I have a large sidewalk, I have a path, I have a stoop, I use absolutely no salt this winter. And so that convinced me that people could really wean themselves off of salt use. And I like to think of it in 3 words, and that this is not ICPRB messaging, but mine, and that is shovel, skimp, and sweep. Shovel first, skimp on the use of salt, and sweep it up. So the 3 S words: shovel, skimp, and sweep. Now, in addition, ICPRB has been partnering with the Isaac Walton League on our Walk in the Woods series. And I must say the Isaac Walton League is really in the forefront of trying to cut down on salt usage. But we're sponsoring a walk with them dedicated to the discussion of salt in our waterways. So the next such salt walk will be held on October 12th in Gaithersburg. Next slide. So in order to learn more about this event and our local waterways, you can sign up for our newsletter using the QR code on your screen. And I'll be happy to answer any questions. Thank you.
Thanks so much, Michael. So that concludes our panel portion, and we're going to open it up to a Q&A. So Nicki and Stan and Michael, we can answer some of these questions together. One question that I saw kind of reiterated a couple of times, and Michael, you mentioned this a little bit about in terms of land use and establishing parkland around the reservoir and then down zoning an additional, I think it was 40,000 acres in Fairfax. And then on the Prince William County side, what we did was with the 1998 comprehensive plan, we established the Rural Crescent, which was created to reduce some of that development pressure in the Occoquan Reservoir watershed as well. And so there is a land use element to this. And so some folks are wondering a little bit about land use decisions and how that relates to protecting the Occoquan. So if anyone wants to,
If I can interject here, ICPRB, working with the Drinking Water Protection Partnership, has developed a land prioritization tool, which we looked at all the parcels in the Potomac Basin, and the parcels, my light went off. The parcels are then identified in terms of their importance to drinking water. And so every parcel gets a ranking, and we use that to go out and talk, and I have given talks to land trusts and to government agencies, and trying to highlight those parcels that are the most important to protect for public drinking water sources. And this is available through ICPRB. And the importance of that is that, say you have enough money to buy one piece of property. Well, and that piece of property, for preservation purposes, is above a drinking water source, and another parcel is below the drinking water source. Well, it makes sense to try to buy the one above the drinking water source, because that's going to influence drinking water. So that's the whole idea. Every parcel is assigned a different number, so that can be a good roadmap for land trusts and government agencies that are trying to preserve land for drinking water purposes.
thanks, Michael. Stan or Nikki, do you want to add to that?
I think that's really smart. I love the fact that you have that tool, because it sort of puts the power in the people's hands in a way, right? You can kind of see where you are, and maybe think about the decisions that you make on your yard, or like you say, on your driveway, in terms of salt use and so on. So I've been kind of monitoring the questions that are coming in the chat. I mean, there's so many smart people on the call today. And we could spend hours kind of probing, and maybe we should have a glass of wine and kick back and enjoy ourselves. So anyway, I'm just really enjoying the conversation, and thank you.
Is there one of the questions in the chat that you'd like to respond to?
So why don't you pick one, Ashley? There's just so many good
I know, I'm going through. Well, I see Harry has his hand up. So Harry, why don't you unmute and come on in?
Yep. Can you hear me?
Yep, we sure can.
Okay. Yeah. I think the excellent program by the Conservation Alliance, and excellent speakers. I want to point something out. Delegate Hinson had a bill in 1352 this year that would have prevented VDOT from using salt and brine on the roads in the watershed. Of course, the governor and VDOT essentially killed the bill. But VDOT did agree to have a town hall meeting in eastern Prince William County in May, that where they would discuss the use of salt and the impact on the Occoquan Reservoir. Just wanted folks to know that, and I'll get a date and let Ashley know when that's going to be. That's all I had to say. Thank you.
Go ahead,
So
Nikki.
I just wanted to comment. Even though it wasn't successful, it started the conversation, right? So now more people are becoming more aware that sodium is an issue in our watersheds and for our drinking water. So if it did anything, it progressed the topic and the conversation in the right way. So I'm happy.
But these issues are so complicated too, right? I mean, like Michael pointed out, we're all putting salt on our driveways. We're taking products in the grocery store and we're using them and putting them And in this stormwater system, that salt is all getting funneled to the reservoir, whether it's de-icer use or product use in the home. And so, yes, I agree. I think it was a great awareness raising, move, but then, issues of public safety, right? I mean, that having an event like that would be really quite a shock to the system, right? Because people would have to change their driving habits immediately. Maybe that's too much to ask. I don't know. Anyway, it's just fascinating to me because we are salt generating machines, and so really to curb that, to cut that back, means to fundamentally alter the way that we live.
Elizabeth Ward, you want to pop in and ask your question?
Okay, so the Rural Household Water Quality Program in Virginia has the largest database of well water in the country, actually. And they discovered in Prince William County, of the wells they've tested, which is a self-selecting group, 40% have water softeners. 15 to 21% of Prince William County is on well water, and an unknown number of people buy water softeners who are on public water supply. There is a lot of salt that goes into those systems, and also is the backwashing releases it either into the groundwater or down the sewer. And so that tends to be a very large source. I know California and lots of places have banned salt-based water softeners. Is that something we can look at? Do we have any idea what its contribution is?
I can take a stab at that, Nikki, unless you want to, or Michael. So I've had extensive, well, actually, I'm going to credit Shannon Curtis, who probably isn't on the call today, but he's a friend and a very smart guy at Fairfax County and working for Fairfax County's stormwater program. And so we talked a lot about this. So the municipal supply here is probably not hard enough to cause most people to use water softeners. Certainly we don't, for example, in my home. And so maybe it's not so much of an issue for homes which are supplied, water safe from Fairfax Water. On the other hand, as you pointed out, the groundwater can be very hard. And so the the use of water softeners and the recharging of the water softeners in particular could be releasing quite a bit of salt, and that, depending on the setting, if it's more rural, could go into septic tanks, for example, which then go into groundwater, which eventually come out into streams. So that pattern that Michael showed, again, you see that seasonal variation over time, where the kind of January, February salt concentrations of the Potomac are rising really dramatically. But you see it across the board, so where is that salt coming from in the summer? It's not directly de-icer runoff, but it's as indirect flow paths that are taking it through groundwater and to the stream, probably in a lot of cases. So I don't know if that answers your question, Elizabeth, but that was kind of the main conclusion that Shannon was trying to. I'm going to blame Shannon. Anyway, he was kind of arguing that point.
I did a quick survey of a couple of Calgon and a couple of other companies, and their number sales are way too high to just be well owners, just for their locality. So they are successfully selling this product to technically people who don't need it for softening. And people believe water softeners do all sorts of magic things. It is the best marketed product on earth, I'm convinced of.
Well, that's another thing entirely what people will buy. So I don't know. That's a great question, Elizabeth. Maybe it is a bigger part of the pie than we know. One thing I can say is that we're working with Fairfax County to go out and we're isolating a neighborhood which drains to a particular manhole. So we'll be sampling hourly at that manhole in the sewer system for a couple of weeks. We're doing the same thing for a laundromat. So we're going into the laundromat, a commercial laundromat, and measuring sort of what they're producing. And then we're doing the same thing for a data center. And then we're looking at the same time at the base of that sewer shed. So basically all of those sources and many more basically coming to the base of the sewer shed. So we're trying to do some of that source tracking to really put quantitative numbers on the relative contributions of different sources within the system. Kind of getting at I think, Jack, you mentioned mass balance calculations, and that's a big part of what we're doing too.
I want to interject that one of the items that was surveyed by the Washington Aqueduct over the years from 1940 to 2020 was hardness of the water. And they found that the hardness increased sharply until about 1980, but then it slowed down. And so maybe somebody has the view of hardness of water from when they were younger, but that's not true now. The hardness in the Potomac River has actually leveled off compared to what it was in the trend line before 1980.
Kim, we'll do Kim Swanson, then Amelia, then Patricia Hickerson. So Kim, do you want to come in? Amelia, do you want to come in while Kim is figuring out how to unmute?
Hello? Hello?
Okay, Kim, we hear you.
Yeah, I was just wondering if there was a way to understand the contribution from the Dulles Airport and whether Dulles is required to treat any of their water and de-icing from their property.
I can share a little bit on that. So I showed you a plot of essentially specific conductance going up with imperviousness in the watershed, right? And the highest end there was Cub Run, which drains a sort of a portion that goes to Dulles. Although some of the runoff from Dulles, as I understand, actually goes to the Potomac, so only a maybe smaller portion goes to Cub Run. But Cub Run receives runoff from a lot of impervious areas, sort of communities that have been built up over time, and also there's I guess a potential TMDL for chloride or salt that was being developed by DEQ, Department of Environmental Quality, and looking specifically at, for example, the quarry there and its contributions through Sand Branch. So it's really astonishing when you start peeling back the onion, how many things are going on. I mean, we think Dulles, how would be and I'm sure they have a lot of controls in place to minimize the loss of salt from their property. I don't really know, but you wouldn't think of the quarry, which I guess was originally built to provide stones for the building of Dulles. so it's just a lot of history and a lot of things going on in the watershed that can contribute to the problem.
And Patricia, you want to come in?
Yeah, three things. I know you don't have time for all three, but so pick one. The biggest one, I guess, is seawater seeping in as the East Coast sinks quite a bit each year, because Savannah, Georgia is already having salt water creeping into their groundwater, their aquifers. The second thing is, next in size, sand or beach sugar, do they increase salinity? I mean, for de-icing, or I guess they don't melt the ice, but are they very effective? I know that there's a beach sugar on some roads, but how about your home? You could use sand. it shouldn't have salt, as much salt in, I wouldn't think. And the other thing is, on the home front, these filters, these faucet filters like Pure, do they remove salt from your drinking water?
A lot of great questions there. So one was about beet juice, and I think alternative deicers are exciting and definitely there's a lot of research going on, and in different areas they've had actually quite a lot of success with kind of using local materials in lieu of salt for road de-icing and so on. I can say also that there is some pushback in some cases, like for example, if you're using beet juice, you're also putting down organic material, which can then fuel bacterial growth, and that can have its own problems. So all of these solutions, you have to think really carefully about the context and whether it's actually having an unintended consequence. So anyway, that would be the extent to which I would answer the beet juice question. And then you had it was something about the pure water filter. I think that the key thing to remember is that salt, and maybe this was in the chat too, salt is a conservative substance. It's not like nitrogen, for example. We've mastered the processes of denitrification, so we can actually remove nitrogen and put it back in the atmosphere where there's a lot of it and it's harmless. So we take reactive nitrogen in wastewater treatment plants and put it back in the atmosphere. We don't have that luxury really for salts. The reason I say that is that you can certainly capture salts in filters. And typically that's an ion exchange process. So what's happening is you're exchanging one ion for another. So maybe you're taking out sodium and putting in potassium, releasing potassium. But the ions themselves are so small that filters don't work. The ions just pass right through the filters, unless you're doing reverse osmosis, which maybe some of these units would do.
How about the sand, though?
Oh,
Sand.
for de-icing. Well, I grew up in Anchorage, Alaska, and they use sand. There's downsides there too. Humidity is one of the things we really worry about in streams because it can affect aquatic life and habitats and so on. So, and if we put sand down on our roads and then that washes into the storm drain systems and then ultimately into streams, that can cause, sort of downstream impacts on the ecosystems. Again, really, do you want to know the honest to God truth? The best thing to do is exactly what Michael said, but I would add maybe another S, stay home. because really it's a behavioral thing, right? The reason that we have so much salt on the roads for de-icing is because we demand to be able to go anywhere at any time under any condition, right? And so if we said, oh, it's inclement weather today, I'm going to stay home, that would change everything.
Thanks, Dan. Randy, you want to ask your question on the sodium loads and data center cooling?
Yeah, thank you. This has been a great presentation. Thanks to all three speakers. My question is this. The data centers in the Occoquan watershed have been expanding at a really fast pace. I know that some of the cooling water discharge from the data centers has a sodium load to it. In the scheme of things, how big are those loads compared to the other, the remainder of the mass balance that you're evaluating? Thank you.
Yeah, no worries. So that's a great question, and I mentioned that we were going to be sampling in the sewer system. And it's not the most fun thing anyone can do, but anyway, we wanted to really get at that answer, and so it was worth it, right? And so we're partnering with Fairfax County's sewer, the collection system folks, to basically answer that question. So we're setting up samplers, but we're waiting until the summer to do it because that's when the blowdown, is more frequent and likely the concentrations are highest. So we're kind of planning that study now. But it's not enough just to say go into a single data center and measure that load over time. You need to compare it to something. And so that's why simultaneously we're looking at the load from a residential community. Simultaneously, we're looking at the load from a commercial laundromat. And then simultaneously, we're looking at the whole load, basically the entire sewer shed at the base where that comes into the UOSA trunk lines. So so I don't think short of doing these kinds of experimental studies, you're going to know the answer. And so we're on it.
Thanks.
Terrific. Well, I told our panelists that we would wrap up around 8:30, and we're exceeding that. And I see that there's still questions coming in. Do we want to? I can share the questions, the remaining questions with the panelists, and I can share that later, or we can continue with maybe one or two more. I don't know if people have a preference. All right. Well, David, you want to pop in, and we can do maybe one or two more, and then we'll wrap it up for the evening.
Yes, it's been a great presentation. Thank you very much. My question's a little removed from sodium in Occoquan, but my concern is with so much reliance upon the Potomac River as a raw water source for our drinking water supplies, and with the continual growing urbanization and industrialization in Northern Virginia, which is directly drawing on that Potomac water that's where it's originating from. The Potomac flow varies from year to year. Is there going to be a point where the Potomac the variability in its flow, it's not going to be able to reliably support this growing water demand that we're levying upon it?
That's a great question, and perplexes us at ICPRB all the time. Our models show that the Potomac Basin is going to get wetter and hotter over time, which is good for water in the Potomac, but the variability is going to increase. So our wet years will be wetter, and our hot years will be hotter, and our dry years will be drier. And so what we have to face is that we need to build in more resiliency into the DC water supply. And one of the things that we're doing is trying to get a study by the Army Corps of Engineers to analyze the various ways that can be done. Now there's a bill pending in Congress for $500,000 for such a study, but that'll be just a down payment on the study. And we're looking at a number of different options. But that's exactly right. Potomac, and I must say that one of the things that surprised me when I came on this job was looking back at our projections on water demand on the Potomac. And each 5 years we do a projection. And originally the projection was going up because of the projected increase in population. But what we didn't project was the use of low-flow toilets and other low-flow appliances and water conservation methods, which have really kept the water demand flat over many years. Now, at some point, there will be a period of time where we're not taking offline those systems that use a lot of water, and so we'll have diminishing returns. And at some point, that graph is going to start going up again. So you're absolutely right. And so that's why we're looking at trying to increase the resiliency by maybe bringing on board another water reservoir. There are three reservoirs right now on the Potomac, and the WSSC has off-river storage in the Patuxent, and Fairfax Water has off-river storage in the Occoquan. But we'd like to have another reservoir brought online to increase the supply of water for the DC area in the future.
Thanks, Michael. So on that note, we'll wrap up this evening, and thank you to everyone can help me thank our panelists, Nikki, Stan, and Michael for a terrific presentation this evening. And I'll be sharing once we have the YouTube, this program is being recorded and we'll be uploading that to YouTube, and I'll be sharing that link once it's published along with the chat. There's a lot of great discussion and information in the chat, so that'll be a good resource as well. And I'm really hoping that this is the start to well, I guess we're kind of in the middle of the salt conversation, but that this is a conversation that we will continue to have and looking for solutions and multifaceted and interdisciplinary solutions moving forward. So hope to see you all at the Bluebell Festival on April 7th. And Sunny Cuffey reminded me that we also have a Kim Hosen Memorial hike planned for May 11th, and would love it to see many of you at our upcoming events. And have a wonderful evening, everyone, and have a good night.